Okay guys, on this video I'm going to go over all the problems on the Chapter 5 test, the blue version. There's also a different video with the green version, so go find that if you had the green test. This is to help you if you need to do test corrections. I'm just going to go through it all in order, so if you need to fast forward through the questions you got right to find the questions you got wrong, do that. First, I'm going to talk about how to do test corrections correctly because some people are still confused on how to do it. Read the instructions, okay, up there and down here. Okay, so this is like, pretend this is on my test paper, this problem, and the blue is how I solved it. I made a mistake. I didn't divide 9 by 3. That 9 divided by 3 should have become a 3. So I got that wrong on my test paper. Okay, so now I'm going to do corrections on it on this white paper. I've got to do all these steps. First, write a sentence explaining what I did wrong the first time. On the first step, I forgot to divide the 9 by 3. Okay. If you didn't even try on the question because you totally forgot it, just write that. I forgot how to do it and didn't answer the question, okay? That could be your answer for part A. Part B, resolve it correctly, showing all the steps. You need to show the steps and you need to write the final answer, okay? Some people did the steps but didn't write the final answer. Some people have just written the final answer from their friend's paper probably, but not shown the steps. That's not going to give you points. Then for step 3, explain your new solution. Okay, so on this one I said, I divided the whole left side of the equation by 3 and the whole right side of the equation by 3, then simplified to find x. Okay, even if you didn't try on it the first time, you've got to do part C. You got to write a sentence explaining what you did do. I don't care what you did wrong the first time. That's part A. Part C is what you did here. Explain what you're doing on these steps to get the answer and why. Okay. Hopefully that clarifies what exactly you need to do for test corrections. Also, down here, when you're finished, staple the paper to the front of your test and turn it in. Don't turn in the test correction sheet all by itself. Staple it on the front of your test paper and turn them in together. If you don't have a staple, you can do one of those things. Okay, but make sure you turn them in together. And if you run out of room on this paper, just use your own paper, use the back, whatever, or ask me for another test correction paper. No big deal. Okay, let's get started on the questions. I'm going to color code things a little bit. Hopefully it will show up on the blue paper. On the first question, the numbers here are -2 and 3. And actually, before I go further, this is really -2 times b cubed times 3 times b squared times b squared. Between all those pieces, I should have just done it right here. They're all multiplied together, and order doesn't matter. So I'm going to take the two number pieces, because those will multiply together, and put them in the front. I won't multiply it quite yet. So -2 times 3. Then I'm going to take all the b's. Everything else that's left is b's. So times b cubed times b squared times b squared. And okay, so this, I just reordered the multiplication, and -2 times -3 would be -6. b cubed times b squared would be b to the 3, 4, 5, 6, 7th power. Okay. B to the 7th power. You add the exponents when it's b to different powers all multiplied together, because it's b cubed is b times b times b. B squared is b times b, and the other b squared is another b times b. So you've got 3, 4, 5, 6, 7 b's multiplied together. That's the product property for exponents that we learned. Okay, let me zoom in a little better here. Okay, so that's number 1. Number 2, -3. I'm going to do this one 2 ways here. So -3 divided by -3 would simplify just to -1 over -1. So, or +1 over +1 actually. So really it's equal to 1a over 1a cubed. Okay, then we've got to deal with the a's, because we want to combine all the a's stuff together. I'm going to show you 2 different ways of thinking about it. The first way is using the quotient rule, quotient property. That's a to the first. So 1 times a to the first, 1 times a to the third, and you don't really need 1 in front on those. So we have a to the first over a to the third. So the quotient property says that's a to the 1 minus 3, which would be a to the -2. A to the -2, it says up here, answers contain only positive exponents. So we've got to change that using the negative power property, whatever we called that, and that will move it to the bottom of the fraction. Flips it because it's a negative. Don't keep it negative when it's down in the bottom of the fraction, because the negative is what flipped it. Now it's not negative anymore. Okay, the other way to think about it is just writing it all out the long way. And again, we don't really need those 1's in the front, because 1 times a is just a. 1 times a cubed is just a cubed. Okay, but that is really a over a cubed, written out the long way, is a times a times a. A divided by a is 1 over 1, right? Say a is 9, it's 9 divided by 9. Say a is 26, it's 26 divided by 26. Doesn't matter what a is. A divided by a is 1 over 1, unless a is 0, in which case that would be undefined, but we'll ignore that for now. Okay, 1 over a times a. Well, I'll leave this 1 for a second anyway. A times a. And 1 times a would be a squared. And there's still a 1 on the top of the fraction. If you wrote a squared for your answer, that's not the same as 1 over a squared. That's different. Like, say a is 3. 3 squared would be 9. So this would be 1/9. We don't know what a is, though, so you got to leave it like this. But careful with, if there's nothing left on the top of a fraction, don't just pretend it's not a fraction. Put a 1 on the top. So either one of those ways is good. You don't need to put both. All right, let's keep moving. Let's keep moving. Number 3. 3k to the third over k. K to the third over k to the first. Just like on number 2, you're going to subtract the exponents and it's going to be k squared. Or if you did it the long way, it'd be kkk over k, and one of the k's on the top would cancel with the k on the bottom. Okay, so that is your final answer. And does it matter if you put the negative on top or bottom or out in the front? No. So that one, that was pretty simple. Only one thing simplified a little bit. That's all you can do. 3 is not the same as 2. Some of you guys tried to divide it out. It's not the same number. You can't do that. Okay, on this one, let's reorder the multiplication on the bottom to put the numbers together and the variables together, or the n's. Okay, n times n is n squared. 6 times 3, we could call that 18. So it's n cubed over 18n squared. 3 minus 2, that's going to be n to the first. Is it going to be on top or bottom? Top. Make sure you know why. If you're confused on that, ask me. If you want to write a little 1 there, that's okay. But the 18 stays on the bottom, the denominator. Okay, let's keep moving, On number 5, you have to remember the power of a power property. Power of a power, you multiply the powers, but you have to do it to everything inside that parentheses, because that's negative 3 to the first. Okay. Multiply that exponent will give us negative 3 squared. And I'm going to put this in parentheses. So that's negative 3 to the first squared. And x to the third squared would be x to the 3 times 2. So we're multiplying here. 2 times 1 is 2. 2 times 3 is going to be 6. Don't forget to do all the pieces, and don't forget it's multiplying, not addition. And there's one other thing I was going to mention here, but okay, negative 3 times negative 3 is 9. Okay, so the negative times negative will go away. X to the 6th. Hooray! Oh yeah, and don't forget, if there's something, whether it's a variable or just a number, that doesn't have an exponent, the exponent really is 1, even though it doesn't say anything. Don't pretend it's 0. It's 1, negative 3 to the first. And number 6, same thing. Gonna multiply that. Is the negative gonna cancel or not? Negative, so we got it cubed. That means there's gonna be negative times negative times negative. 2 negatives will cancel out. 1 will still be there. So that's gonna become b to the 6. Just show that the long way super quickly here. Negative b squared, negative b squared, negative b squared. So to put all the negatives in front, that's like negative 1 times negative 1 times negative 1 times b times b times b times b times b times b. So that shows you why there's a negative left there in the answer there. Okay, number 7. Before we try to multiply this stuff times this stuff, you've got to apply the exponent. Okay? This isn't a negative 2, it's a negative 2 to the third power. You can't multiply the 3 times negative 2 and get negative 6. That would be not good. Okay. So we're going to leave the 3x alone for a second. And we're going to do what we did up on number 5 here. So negative 2, that's to the first, I'm going to multiply that by 3, and x to the third, I'm going to multiply that 3 by 3. That's the power of a power property that we learned about. Power of a power, multiply the powers. So now we're going to have negative 2 to the third, and then we're going to have x to the 9th. So that's 3 times x times Negative 2 to the third, is that going to be negative or positive? Think about that for a second. Negative, just like we did on number 6. So that's going to be negative 2 to the third, 2 times 2 times 2. It's not 6, it's 8. Careful with that. And then x to the 9th. Okay, then I'm going to multiply my numbers together. I'll just do this in one step. Negative 24. And I'm going to multiply x times x to the 9th. Remember, that's x to the 1st, so that's going to be x to the 10th with the product property. I mean, not, yes, product property. And that's your answer for number 7. Number 8, squared has to go to all the pieces. I'll do this 2 ways, like we did on that one earlier. Hopefully the camera is not... Okay, there we go. So first way, I'll just go like this. Those are all 1s. So it'll be 3 squared times x squared times 2 squared times x squared. And then that will be, you could put the numbers in the front, 2 squared times 3 squared, x squared times s squared would be x to the 4th. And yeah, I'll just leave the 2 squared times 3 squared how it is. Okay. Other way to do it would be to simplify the inside first. Before you apply the exponent, we can, on the inside, 3 times 2 is 6. X times x is x squared. And that's really 6 to the 1st, right? But then, go like that. And 6 to the 1st squared would be 6 squared. X squared would be x to the 4th. And is 6 squared the same as 2 squared times 3 squared? Let's see. 6 squared would be 36. So you could also put 36x to the 4th. And 2 to the 2nd would be 4. 3 squared is 9. And 4 times 9 is 36. So yeah, they are the same. So if you put any of these, I counted that as correct. Okay. This one right here. And again, you don't have to do it both ways. You only have to do it one way if you're doing corrections or whatever. Okay, so on number 9 now. Let's reorder this. Negative 4 times 2. I'll just cross these off as I go. X to the 0, that's 1. That's 1. X to the 0 equals 1. So that's 2 times 1, which is 2. So that x to the 0, just it adds a times 1, which doesn't change anything. So the only x that's really there is x squared. Then the y's, so I got the x squared, the y's are going to go here. Y to the 4th times y to the negative 3. Okay, negative 4 times 2 is negative 8. Easy peasy. Okay, multiplying these, that means we're going to add the exponents. 4 plus negative 3 would be 1. Hooray! And if you don't want to write the negative 1, I mean the 1, you don't have to, because times y would be the same as there'd be an implied y to the 1st there. Okay, good. Okay, let's go to number 10. Ooh, the negative 3's got a 1 on it. Let's first do the power of a power property, then we'll deal with the negativity of the exponents. Okay, so we're going to have negative 3 to to the negative 2 power times y to the negative 2 power. Okay. Negative 3 to the negative 2 power. That is the same as 1 over negative 3 to the second power. Okay, the negative flips it. The 2's still there on the bottom. The negative's not still there because we flipped it. That's what the negative in the exponent did. Don't mix up negatives like this or like this with negatives in the exponent. Only flip it if the negative's in the exponent. A couple people were confused on that. Okay, and y to the negative 2, that means it's going to flip to the bottom and be y squared. And then there's a couple ways you could write that. Negative 3 times negative 3 is going to be positive 9. So 1 over 9 y squared is good. Or if you wrote 1 over 3 squared y squared, that's okay too. But then since the negative is going to cancel out there, okay, on the bottom you have negative 3 times negative 3 times y squared. Negative times negative is a positive, so that negative is going to cancel out. So hopefully you didn't put a negative in the answer. But remember, this negative, it only goes away because it's squared. Negatives, if it wasn't squared, you just leave it there. It's not in the exponent. Negatives in the exponent is what you really got to care about. Okay, 2 ways on this one. These will be super fast. So first thing is you could say, oh, look at that. That's a thing. It's a thing to what power? The 0 power. Anything to the 0 power is what? 1. That's a thing to the 0, so it's 1. Or you could do it the long way if you really want to. Say, oh, that's negative 4 to the first power. And so I'm going to do the power property and say it's negative 4 to the 0 times y, 3 times 0, 0, 1 times 0, 0. And negative 4 to the 0 is 1. And y to the 0 is 1. And 1 times 1 is 1. Okay. Hopefully you could just tell, oh, the whole thing's to the 0, so the whole thing's just 1. But if you did it the long way, that's great too. Okay, number 12. 4 over 2. What's 4 divided by 2? 2. Y squared over y. If you want, you can write y to the first to help you with that. It's going to be a y on the top to the first, if you'd like. X to the negative 3. It's a negative exponent, so it flips up to the top. We talked about that. X to the third. Oh, the 2 went away because 4 over 2 was 2. The y went away because we simplified the y and that was left on the top. This went away. There's nothing left on the bottom, so it's over 1. So really we just have 2. I'm going to put the letters in alphabetical order because I want to. If you didn't, that's fine. There you go. Nice and easy. Just the negative power on the bottom moves it to the top. You got to remember that part of the negative exponent property. Let's go with that. Okay. There's several ways you could do this depending on what order you do the steps. So I am not going to try to show all of them, but I'll show you one way to do it. So b to the 0 is 1. So it's 2 times a to the negative 3 times 1 times, times 1 times b cubed. All to the, all over, it's, that's a 1 times b to the fourth. And that whole thing to the negative 3. So really it simplifies quite a bit right away if you are paying attention. So all I did there was change all the b to the zeros to a 1. And stuff times a 1 is just that same stuff. Okay. There's two ways you could go here. One way, which would work perfectly fine, is to multiply the power to all the powers on the inside. So -3 times that, times that, times that, times that, and then simplify stuff. I'm going to go the other way and excuse me, simplify the inside as much as I can before I apply the -3 power to stuff on the inside of the parentheses. So the 2, there's no other numbers by themselves, so the 2 will just have to stay there. A to the -3, since it's got a negative power on it, it's going to go to the bottom and become a to the +3 in the denominator. Okay, this b to the 3rd divided by b to the 4th, I'll show it in 2 steps. That's going to be b to the -1, because 3 minus 4 is -1. And then I'm going to say that's the same as 2 over a to the 3rd times b to the 1st. I'm going to put 1s on those just for the... Okay. Now I'm going to do what I was talking about earlier. Take this -3, because it's a power of stuff, and all the stuff in there has powers on it. So you got a power of a power it. You have to do all the factors in there. Okay, don't just do the b and forget about the a, or just do the 2 and forget about the stuff in the denominator. So you're going to get 2 to the -3 over a to the 3 to the -3 times b to the 1st to the -3, which will be, I'll leave the negative exponents for a second. 3 times -3 would be -9. -3 times 1 is -3. Now I'm going to flip everything that's got a negative exponent, which is pretty much everything. So 2 will go down to the bottom and be 2 to the +3. Those will come up to the top. A to the +9, b to the +3. There we go. And see if we can get this video under 30 minutes. 3 times what is 12? 4. 12 times what is 48? 4. 48 times what is 192? Check with your calculator. Divide this divided by 48. It's 4. It's multiplying times 4 every time, so the common ratio is 4. The first one's the easiest one to tell there. Then you check it's doing the same thing every time just to make sure. Now find the next 3 numbers in the sequence. So you got to do, so the next one is going to be 192 times 4, which is, oh, I've got to grab my calculator. 1 second. 192 times 4. And then we're going to take that and multiply by 4 to get the next one. And then we're going to take that and multiply by 4 to get the third one. Okay, here's my calculator thing on my computer. I'll just type that in really quick. 192 times 4 equals 768. So that's the next one after, so 3, 12, 48, 192, 768. And then times 4, enter. Whoop. Pressed enter twice. So that, the third one I believe should be that. let me start over. 768 divided by, not divided, 768 times 4 equals 3072. And double check the next one, multiply that by 4, and that is 12288. Okay. So there's the next three numbers. Find the explicit equation. Hopefully in your notes you had, oh, it's just a sub n equals the first one times the ratio to the n minus 1. If you had that in your notes, then all you have to do is plug in the numbers. A sub 1 is 3 times the ratio is 4. And it's not to the n, it's to the n minus 1. And then how do you check that that's right? What if n is 1? Do I get 3? 3 times 4 to the 0. 4 to the 0 is 1. That's 3. If I put in n equals 2, will this give me 12? 3 times 4 to the 2 minus 1. 2 minus 1 is 1. 4 to the 1 is 4. 3 times 4 is 12. If you put in your calculator, let's see, that's 1, 2, 3, 4, 5, 6, 7. If you put in 3 times 4 to the 7 minus 1, or 3 times 4 to the 6, it'll give you this. So you can always check it with your calculator really easy. The only confusing part is you got to write n minus 1, not just n. So starting number, ratio, and it's n minus 1, not n. Because the first time you're not multiplying by 4 to get the first number. So you multiply by 4 one less time than which number in the sequence you're at. So to get the 6th number in the sequence, you only multiply by 4 5 times. So 4 to the 5th times 3 would give you this one. Okay. That's the test.